So the law of sines that we've been using, in order for it to work, we have to have an angle side pair. In other words, we have to know like angle A and side A, or angle B and side B, or angle C and side C. But if the angle I'm given is the side I'm trying to find, it won't work. For instance, if I give you angle C, side A and side B, I can't set up the law of sines because I don't have the correct information. So there's actually another rule that works in that case, and that is the law of cosines. So in this, it's again any triangle, so it does not have to be a right triangle. This is a formula I would give you. There's 3 variations depending on which side you are solving for. So it's a squared equals b squared plus c squared minus 2bc cosine of a, and then the same for b and c. The last one, a squared plus b squared. If c is a right angle, then this is something we've seen before. Because if c is a right angle, c is 90 degrees. What's the cosine of 90? And sine is 1. Cosine is 0. So this whole term would drop out and it'd be a squared plus b squared equals c squared. So the Pythagorean theorem is actually a special case of this formula. But this is more generic and allows us to find any side in any triangle. So let's look at an example. A surveyor wishes to find the distance between 2 inaccessible points A and B on opposite sides of a lake. While standing at C, she finds side B is 259, side A is 423, and angle C is 132 degrees, 40 minutes. We need side C. So what I gave you is a side, the angle between them, and another side. Do you remember in geometry you call that side angle side? You had all those different relationships. I cannot do the law of sines because the side I need is the angle I don't know. Or, sorry, I don't have an angle side pair. The angle I know is the side I don't know. The sides I know, I don't know their angles. So that's when we would do law of cosines. We're looking for side C, so we would do the third one. C squared equals a squared plus b squared minus 2ab cosine of angle C. Plug in A is 423, B is 259, is 2, is 423, is 259, cosine 142 degrees, 40 minutes. Now, if you're trying to find C, how would you get rid of the square? Square root. That would give you a plus or minus, but can C be a negative? We're looking for a distance, so it would have to be positive. So I'm just going to type all of this in. So I'm just going to do the square root of this whole thing. 423 squared plus 259 squared is 2 times 423 times 259 cosine 132 plus 40 over 60. And what'd you guys get? It's a lot to type in. That's 628 meters. I said 2 boats leave a harbor at the same time. traveling on a course that makes an angle of 82 degrees 20 minutes between them. So I didn't tell you directions, I just said they left from the same place, going different directions. The angle between them is 82 degrees 20 minutes. When the slower boat has traveled 62.5 kilometers, so I don't know which one's the slower boat, but just label one of your sides. The other one has gone 79.4 kilometers. Trying to find the distance between my boats. So the case when we use this law of cosines is always when you have side angle side. Two sides and the angle between them. Because the side I'm given does not match up with the angle I'm given. I can call these angles whatever I want. If you want to say that you're looking for side C, then this would have to be angle C, this would be my side A and side B. So we could do the same formula. So if we plug in C squared equals 79.4 squared, 62.5 squared, is 2, 79.4, 62.5, cosine 82 degrees 20 minutes. And if you want, you can go ahead and just do the square root of that whole thing when you plug it in. How are you?
Pretty good.
And I got 94.3 kilometers. Any questions about using those? Okay. We'll pick up with some more tomorrow, but that's the